Radical Dude here, and today we're going to be learning about area of a circle. I'm going to prove the formula. I'm going to prove it to you two ways. One, using polygons, and the other, using calculus. Okay? So, let's first start. There's a few ways to do it using calculus, but I guess the easiest method is to use shell integration. So here's how we do that. We want to find a formula for area of the circle. Well, you're making an infinite amount of circles, right? We're making an infinite amount. And we're going to add them all up until you get to the outer edge. So you're infinitesimal, right? That's how it goes, until you get to the whole thing. Well, the circumference formula, this length all the way around is 2 pi r, right? So the circumference is 2 pi r. And what you have is you have different, here, let me just make it a little bit clearer. You have different r's. We'll call this r1, this is r2, r3, and it continues, right? So we're, in essence, we're adding up all these r's. And it goes on. Well, that can take, you know, a long time. So what you do is calculus was invented. We'll call this all the way to the end, let's call it capital R. Okay? So the smallest circle we're going to get is 0, right? The radius could be 0 all the way to R. So here's how we do it using calculus. We're going to say that the area, we're going to integrate that formula 2 pi r. Okay? Now, what we're doing is, what is the increase we're making? This little increase as we're getting the circle bigger and bigger, and it's infinitesimal. We'll call it dr. Okay? Delta r. That's how we're increasing the distance between those little circles I drew. Okay? So we write it over here. dr. Now, where am I going from? I'm going from r, when I'm going from r1 all the way to rn. Let's call this big R when we finally get there, and we can call this 0. The smallest radius is 0. So we're going from 0 all the way to our R. So over here, I put 0 all the way to the R. Now this is a constant 2 pi, so I could pull it out. And I'm left with going from 0 to R of r dr. So we're integrating the radius, right, with respect to r. Well, how do I do this one? First, this is a constant, and now, and it is r squared over 2, as I'm going from 0 to r. Well, what happens here? These twos can cancel out, and I'm going from, well, how do we do this? Well, this is equal to pi times capital R squared minus pi times 0 squared, and that equals pi r squared. So there's your formula for error. Remember? We're using a capital R in this case to distinguish. So there's the formula. Well, this has been Radical Dude, and I hope you learned something.